Hello everyone, myself Maheshwaran. So this is my 7th task at Need Data for my data science internship. So today we will be performing BigMart Sales Predictions. So in today's task we will be covering all these 20 steps. So from this you can understand that these are some basic and necessary steps that needs to be followed in developing a machine learning model. So here you can see my datasets are present. My test and train dataset is present. My train dataset has everything for training, and my test dataset doesn't have my target column alone, and here my Jupyter notebook is present. So we'll be loading those into our Jupyter notebook, and we'll be developing a model, and using that model we'll be making predictions for this test dataset. So the first step is to understand our problem statement. So the main goal of this problem statement is that we have a data set which has all the informations about 1600 products in it from 10 stores in different cities. There are totally 10 different stores present in 10 different cities. The different cities, what it means is that urban and rural, all those things. So that's the data set. So we need to develop a model that predicts the sales of a particular product in that store. So that's our problem statement. So this is a supervised learning problem because in the trained data set we have all the target variable also, and this is our target feature. So this is what missing in our test data set. So we need to make predictions for this column only, which is the numerical column. So our first step is over. We have understood our problem statement. That is, we have the information of all the products and we need to make a prediction for this column alone. And we have all the training data set to train our model. So next comes the hypothesis generation. So this is also some basic things that needs to be done for any machine learning model to be built or any data analysis. So first, based on the item, we are making two hypotheses, and based on the store, we are making two hypotheses. So based on the item, the first one is item visibility in store. From this itself, we can understand that in a supermarket or in any market, the visibility of a product is more important. So if it is in the front itself, which catches the customer's eye, so it can be purchased and the sales will be great. So that's our first hypothesis. And the second hypothesis is product frequency. So if a particular product is selling again and again in a more frequent way, so from that also we can understand that this product is a best-selling product or all those things. So that's our second hypothesis. And next is based on store. So it also depends on the store, right? So when it comes to city type, you can say that people in a city or people in an urban area tend to purchase more products compared to the rural people. So that is also seen here. So next, store capacity. So what it says is that if the space of the store is big, so meaning if the store is like a supermarket or some other place, so you can say the purchases will be, or the sales will be higher compared to the stores that have the basic things in it, like only dairy products are present and all those in all those stores the sales will be lesser. So that's the last hypothesis. So these are our 4 hypotheses that we made. So moving on to the next step, here is where our programming part starts. So from now on, we'll be loading a trained dataset and do all the necessary things. Like we will be loading our trained dataset, and we'll be looking at its content and all those things, and we'll be performing exploratory data analysis on it, and missing value treatment, feature extraction, encoding them, and outlier removal, all those things. So we'll go step by step. So first, I'm importing all the necessary packages, NumPy for algebraic data and pandas for data manipulation and analysis, math for any mathematical applications, and these two for data visualization. And we'll look at each and every function when we are using them. So we'll start. First, I'll import all these packages. And after that, here you can see I'm loading my dataset under the variable train and test. So here we are using this read_csv function, which is present under the module pandas. So using this function, I can load my dataset. So inside the bracket, I need to pass the path for my dataset. So here you can see the dataset is present along with my Jupyter Notebook. So I just need to pass the name of our dataset along with its extension. So first I'm doing that. I'm loading them under the name train and test. So after that, so using the head function, I'm looking at the top 5 records of our dataset. So here you can see these are the things present. So the first step is to understand our dataset. So from this you can see there are, so I'll do this. So using the shape function, you can look at the dimension of our dataset. So from this you can get some 8,500 products present in our dataset, and it has around 12 columns. So these are the 12 columns. So the first one is item identifier, which is nothing but the ID for our item. And the next one is item weight. So this is our product's weight, which is in the units of kg, I think. So that doesn't matter. So then comes the item fat content. So from this you can understand that the presence of fat in the particular product is given here. And the next one is item visibility. So this is one thing that we have seen earlier. So the item's visibility also affects the sales of a particular item if it is in the front, or if it is easily seen by the customers, then they will purchase that product. So the item's visibility is also shown here, meaning for example, these items are may not be in the sight of our customer, and these are there, but the percentage is given here. And the next thing is item type. So this shows the type of our product, and item MRP shows the price of our product, and outlet identifier. So this is the ID for our shops. So the shop name is OUT049. So this is the ID for one of the 10 shops, and this is for another shop. So this column is at, and outlet establishment here says the shops opening year. So this shop, the shop with the ID OUT049 is opened in year 1999. So that's the information given here. And outlet size. So this shows the size of our shop, so which is medium. And outlet location type. So from this you can see the location in which our shop is present. So there are 3 types, I think. So we'll look at them. So first I'm calling my data set, and in that I need to make slicing. So I need to select this particular column. So for that you can type it by yourself. For now I'm copying and pasting it. So the casing is also necessary here. For example, if the O is small, now this one is correct one. So for example, if this O, for example, if I'm replacing the capital O with small o, you can see that there is some error thrown. Key error is thrown saying that this column with this name is not present in our data set. So it is case sensitive too. Be sure about that. And after that I need to know the categories under this variable itself, under this column itself. So for that I'm using this function called value counts. So basically this value counts function can be used in places of categorical columns. So what it does is that it will give a frequency table kind of thing. So from this you can see that there are 3 tiers present, and we have counted the numbers present in each and every tier. So in tier 1 there are 2,400 records, and tier 2 2,700 records, and tier 3 3,400 records. So there are 3 tiers present. It could be anything, like tier 1 could be the main area, or tier 3 could be the main area. It depends, and it is calculated. Our machine learning algorithm will calculate it based on the sales it has and all other calculations. So the next thing is outlet type. So this is the type of our outlet, type of our shop. So for example, whether it's a supermarket, in that itself we have two types. So type 1, type 2 and all those things. We can also look at them. So just I'm copying it and I'm replacing it here. So from this you can see there are 4 categories present under it, which is supermarket type 1, supermarket type 2, type 3 and grocery shop. So these are present here. So finally, item outlet sales. So this is our target variable, which shows the sales of this particular product present in this particular shop. So that product is sold for some 3,800 rupees in this shop. So that's the information this has, and we'll be finding this information only for our test data set. So you can see, so this test data set doesn't have that column. We'll look at that. So these are the basic information. So from this itself, you have to understand all the contents present in our data set. I think if we are clear with the contents, like this is the basic things. Outlet is nothing but our shops. So outlet identifier as the shop ID and all those informations. So these are some basic informations. So after that, I'm looking at the each and every category present for each and every variables, like each and every columns. So for item type, there are some 5, 10, there are some 16 categories present under the item type itself. So there are 16 product categories in it, and that's what I'm looking at. And the shape function gives the shape of our data set, meaning the dimension of our data set. So you can see there are these much rows and these much columns, and rows meaning our records and columns meaning our features. And using this info function, you can look at some basic things like you can list the columns and the non-null values present in that columns, and the data type of that particular column. So that's where this info function is used. So after that, this is the feature description that I said earlier. So if you have time, you can pause the video and look at this. So this is very important. We need to understand our data set first. So we have made a further category like numerical features and categorical features. I suppose you all know what numerical features say. All those information said in numbers are called numerical features, and all other things like other than the numerical thing, like this has letters in it, alphabets in it, and all other things are considered the object data type, or it is considered as categorical variables, categorical features. So these are the numerical features, which are item weight, item visibility, which is in the form of percentage, and item MRP, items price, and the shop's establishment year, the shop's opening year, or the shop's or the particular item sales in that particular shop. These things are numerical features, and these are the categorical features. Okay. So moving on to the next one, this description function can be used to look at the statistical summary of our data for each and every column. So without this parameter, without this argument being passed, you can see, so we have done the descriptive summary only for some 5 columns. So only these columns are considered as numerical columns. As you have seen earlier, you can see only for numerical columns, it will perform statistical analysis. So to include all the numerical and categorical columns, I am using this function like include equal to all. So this will give the statistical analysis for each and every column. Item fact counted is a pure categorical column, which says the fat content present in our particular product. So from this you can see there are only 5 things, and the top value is low fat, which is repeated for 5,000 times. So if you are insisting on calculating the descriptive summary for all the columns, this is how you will get. Only the first 4 things will be calculated, and all other things will be given as null value. So after that, I'm checking if there are any null values present in our data set. So using the isNull function, it will return false if there are any non-null values present, and this sum function will sum them up, and using this one I'm sorting them. So without this, you can see we have got the null values present in each and every column in the same order it has. So to sort them according to their values, I'm using this sort values, and inside that I need to sort them in a descending order. So I'm setting the ascending as false. By default it is true, so I'm setting it as false. So you can see there are two columns having the null values. So it is outlet size and item weight. So outlet size is nothing but the size of our shop, whether it is a small, medium or big one. And item weight is the weight of our item. So these are the two things that has null values present. So we have seen, so even we have them here, right? So for the outlet size, so from this you can see medium is the mode, I think. So medium will be our mode, which repeats like some 2800 times. So this medium will be selected and medium will be replaced for each and every null values. Like for every 2400 record null value records, we will replace them with medium value in it. And for the item weight, this column's mean is item weight. So the mean of this column is 12.85 and we'll be replacing all the 1400 records with this value. So that's what we'll do. You can see. So is there something? So I'll be attaching all the Jupyter notebook and all those things. So if you are interested and if you want to have a great look at it, you can look them. You can use that. So for now, I'll be running all the codes alone and I'll explain everything. And I won't be reading everything present in here. So here I have just looked at them and I have noted that there are null values present in our data set. And before itself, we can make a plan, or you can just note that null values are present and we must be dealing them. So for now, we are just looking at the data set. So I'm looking at the outlet establishment here. Its data type and all those things. If it is not in the integer data type, I'll be converting them into the integer data type. So I'm looking at the outlet establishment here. So after that, I'm looking at the outlet identifier. So from this, you can see there are 5, 10. So as they said, there are 10 IDs present here, each ID for each shop. So there are no problem here. So now we need to look at the test data set. We have already loaded them initially. So this is our test data set. So all other things are the same. And next step, we are going on to the exploratory data. So this is the basic analysis we must perform for knowing our data set. We'll be visualizing only for a single feature now. So that's called univariate analysis. So in that itself, we have two classes, right? For numerical columns, we will be performing different things, and for categorical columns, we'll be performing different things. So first, I'll go with numerical columns. So first, using this select d types function, I'm selecting all the numerical columns present. Okay. So this one will return the data set with only numerical columns, meaning only with float 64 and int 64 data types. And in that, I will only extract the column names alone. So to extract the column names alone, I'm using this function dot columns. And after that, I need to convert them into a list. So if we are not doing this, then it might be, output could be in the form of, a series or something like that. So which will have indexes and all those issues. So better convert them into a list. So you'll have only the column names present. So you can look, there are only, as you have seen earlier, there are only 5 numerical columns. And I'm performing a descriptive analysis on it. So without this t function, this is how you get. And using this t function, you can have a transpose of your data frame. So that's why I'm using this. So our first visualization will be a disk plot. So first I'll plot them, then explain them. So this is our visualization. To plot that, first I need to make a space for them, right? So first we'll look at this part. So why PLT? So PLT is for match plot lib. So you can see the alias for it is PLT. We have said that here using the function AS. So I'm calling that, and under that only I have this subplots function. What the subplots does, without this one we'll be having a single plot, right? So for now we'll be plotting for 5 different columns. So I'm using the subplots, meaning so this plot is a subplot and this is another subplot. So for this purpose I'm using this subplots function, and inside that I need to pass the number of rows and columns. So here you can see it is in a single dimension. So the number of rows is single row and 5 columns. So n rows is 1 and n columns is 5. And the size of our graph should be 26 cross 4. So if I click at it, you can see the original size. You have to double click it to look at the original size. So that's the function of this particular line. So this AX has the index values present in it. For example, here there are 5 subplots. What if you need to access this one alone? You need to change the title for this plot alone. So it must have some index type. So if there are 5 things present, this one has the index as 0, this has 1, 2, 3, 4. So that's this first line does. So only with this first line, I'll run this one. So from this you can see this is what we get from this one line itself. So using the print function, you can print them in a single line. So that's the reason I'm using this print function also. So you can see these are the elements present inside the numerical columns variable. So using this enumerate function, I can store the element value, which is item weight in the COL, and also the index of this one under the name index. So that's the reason I'm using this enumerate function, or else I can just simply, without this itself I can write, but I won't be getting 2 values, only one value. It should be the elements present in that list. So I'm using that. So after that, inside that, for example, in the first iteration, my index will be 0. So this will be our element. So our index will be 0 and our COL will be our item weight. So in the first iteration, this is our information. I'll write on here. So index is 0 and item weight. Okay. So this will be our first in the first iteration, this will be our values. I'm using this function called dist plot to plot the distribution plot. So first I need to pass the variable. So drain is my data set and I'm slicing them with the name item weight. So our column has the value item weight, right? So I'm using that. Now I need to specify its index, right? So that's the reason I'm using this one. So AX will be AX of index. So now our index will be 0. So AX of 0 will be the first one. So that's how it navigates and finds the proper position. So next I need to write the title for our plot. So that's the reason I'm using this one. So this function is purely for finding the position and location of our graph. So I'm calling that, and inside that, using this set title function, I'm writing my title. So that's it. That's how we got this one. So for example, to understand it, to make it more understanding, let's say this is our graph. So I want to write something in here. I want to write this one as a middle one. So the title for this one must be middle one. So I know the index is right. This has 0, this is 1, this is 2, 3, and this one is 4. So from this you can see this is the need for this AX function. So our AX function has this one only. So that's it. So that's how we drew this one. So from this you can make analysis, and I've written all those things here and you can read this. So after that we are performing a KDE plot itself. So the same concept is repeated here. So under sequence I'm using this KDE plot to draw the distribution line alone. So all other things are the same. And I'm also drawing a box plot. So usually we draw box plot to know the outliers present in our data set. So from this we can understand that this second and fifth one has some outliers present in it. So we are noting them. So we have also noted that several columns had, I think 2 columns had some null values present, and now we are noting this one has, these 2 columns has outliers present in it. Finally, I'm drawing a Violin plot. So Violin plot is also used to identify present. So from this you can see this straight line is considered as outlier. So these 2 things has, these 2 columns has outliers. Now we have done visualization for the numerical column alone. Now we will be performing for categorical columns. So first I'm selecting using the same function. At this time the columns with the object data type. So you can see this is the output. First I'm selecting the unnecessary columns alone, and I'm showing the frequency table of each and every column using this one. This is a simple Python program. You can see I'm running a for loop for each and every element present in this variable, and for that I'm using this value underscore counts function and making a frequency table for it. So you can see that. But so for the outlet location type, you can see there are only 3 tiers, and I'm looking at the categorical columns to be displayed. So now on we'll be plotting graphs for these categorical columns alone. So first the same content here. So but this time we have different rows and different columns present. So you can see there are 3 rows and 2 columns present. So from this you can see that I'm using the same subplots function, and number of rows are 3 and number of columns are 2, and the figure size is this. So first I'm writing this one, and we have already seen the explanation for it earlier. And after that I'm running a for loop. The same thing we are doing here, but the thing is this is in the form of 2 dimension, right? So consider this as a 2D matrix with a dimension 3 cross 2. So for example, the name of the first element in the matrix would be 1, 1, and second one would be 1, 2. This one is 2, 1, 2, 2, 3, 1, 3, 2, right? So but in this case same concept, but it starts with 0. So name of this one would be 0, 0. This one would be 0, 1, 1, 0, 1, 1. So these are the indexes of each and every element present inside this. So inside this matrix, so we need to find them, right? So for that I'm writing these 2 lines. R stands for row and C for column. So we can get the row number just by taking the quotient present, and for the column we can take the remainder itself, and all other things are the same. Like under the achievements I'm using this count plot function to draw the count plot for them. So the train will be our data set, and the x-axis will be our column. So our column will be the elements present inside this list. So and the index will be ax of rows into columns. So in the first time our index will be for example index is 0. So our remainder will be so our quotient will be 0 and our remainder will also be 0. So the first time our index will be ax of 0, 0, which is the first one, and the width of the each 0.5. For example, 1 being the complete bar. So I want gap in between every bars. So for that I'm writing like I don't want the complete one, I want the just the 90% of it. So you can see there will be a gap present in between them. So that's the reason I'm writing. And using this function you can write all the writing part for your x-axis. And you've seen this earlier. Using this one we are writing the title for our graph, and I'm using this one just for them to be I don't want the labeling to be overlapping to other graph or all those things. So that's the reason I'm writing it as tight layout. So for this time we are plotting a pie chart. So using the same thing is followed till here. And after that, for every column, first I'm taking the frequency table of it. And using this plot function, I can plot any plot. So by default, it will plot a line plot. For example, if I'm removing this one, so if it is a numerical column, it will plot a line plot. So since it is a categorical column, you need to specify the type itself. So I need to specify it as pie. So the kind is pie. So we are plotting a pie chart, and all other things are we have seen earlier. So I'm moving on to the next one. So these are the observations that we made. So after that, we are doing bivariant analysis. So usually we'll be using this scatter plot only for bivariate analysis. Mostly in most of the cases, we'll be performing scatter plot only. And after that, a heat map will be performed. So first, all other things are the same. First, I'm setting up my target variable as the target column, and only for these things, I'll be performing the scatter plot between item weight and item outlet sales and all those things. So here you can see everything is same, and I'm using the scatter plot function under Siemens, and our data set is our train data set. So I'm passing that, and our x-axis is the column, and our y-axis is our target column, and this shows our position or index of our graph. And in this line, I'm writing the title for our graph. So you can see we have done that. So that I'm doing the same thing, but this time I'm using this hue function has separate talent, which is, so instead that you need to pass a name of a categorical column. So it will differentiate the output based on that categories. So inside that I have passed outlet type. So you can see it has drawn the scatter plot with color differences. So you can see there are so you can see the output. So after that, first I'm looking at the data types. Then I'm just selecting the object columns alone. So these are the object columns. So I can see there are some 7 object columns present. I can only make heat map for the numerical columns. So I'm selecting the data types of my columns to be integer or float, and this returns a data set that has only the specified columns with these data types. So after that, I'm using this CORR function to make a correlation list, and that is passed into a heat map. So inside this heat map function, if I'm passing that, it will draw a heat map for it. So you can see this is it, and you can also set the color for it. So for changing the color, you need to use this function called CMap, which is the color map, and inside that you can pass the color. So this is the method. You need to pass the method in which they must be colored. It's a rainbow. So you can see the change is made. And now we need to perform the bivariate analysis for numerical columns too. So I'm simply plotting a bar chart between our target variable and the x-axis. Our x-axis is the outlet size column. So between the outlet size column and our target column, I'm plotting a graph. So there are only 3 sizes: medium, high and small. We are done with the analysis part. Each and every analysis that we have made, we have noted all the outliers present, all the missing values present in our data set, and some things like from this you can see for this item fat content column, you can see this low fat with a small L and LF, all these things are same, and regular are same. So we need to process that things. So far we have understood those things. So our next step is missing value treatment. So till now we have done our visualization part and all those things, but we haven't changed anything in our data set. Like we have noted several things like which are the columns that has outliers, and the columns with null values, and the columns that needs to be altered, and all those things. So for now we have just observed our data set, and from now on only we will be treating our data set according to our So first, treating the null values present in it. So from this you can see there are null values present in 2 columns. So you can see these 2 columns are in, so the first one is in numerical column and the second one is categorical column. So for the numerical column, I'll be replacing it with the mean value, and for the categorical column, I'll be replacing it with the mode value. So that's what I'm doing here. So you can see first I'm changing for outlier size. So for this column, so let's navigate from here. First I need to take the mode value of it. So first I'm selecting the data set, and in that I'm selecting the column, and immediately after that I'm dropping the null values present in it. So meaning to calculate the mode for a particular column, there shouldn't be any null values present. So if there are any null values present, so there are some null values present, like some 2400 null values are present. First I'm dropping them, and with the remaining one I'm making a mode out of it. So from this you can understand that the output of this one would be in the form of series. So I need to select the value alone. For that reason I'm using this indexing function. So the first one would be selected. So for example, you can see this will be the output. In that I need to select the value alone. So that's the reason I'm using this slicing here. So this one we have got the value medium. So now I need to replace it for the null values. So for that, here I'm selecting the column. So this one is purely for getting the mode value, for which we have got the value medium. So first I'm selecting a data set, and in that I'm selecting my column. So to fill in the null values, I'm using this function fill. So inside that I need to pass the element that is to be replaced in the place of null values. So that is our medium. So that's the explanation for this line. And for the item weight column, we are doing the same thing, but this time we are selecting the data set, we are slicing the column, and we are directly going on to the mean values. We need not drop any null values present in it. It will calculate the mean values with the elements present alone, and it will give the direct answer itself. So for example, copy, paste. So from this you can see the output is in the form of single numerical value, and the type of it is an numpy float, which is just a number it is. So that's the reason I'm not indexing it or anything. So this value has the value, so this part gives the value 12 point something, and I'm using the same method, like I'm selecting that column, and in that column I'm using this fill function to replace the null values with the parameter passed in it, which will be 12.85. Oh, I'm repeating the same for the test data set also. So no changes between these two except for the name. And after that you can see there are no null values present in my data set. Same goes for the test data set as well. So you can see the null values are treated. So our next step is feature engineering. So now we'll be looking at the outliers and all those things. So now we'll be focused on a particular column itself, which is also called as a feature. So to replace the outliers, I'm using a technique called interquartile range method. So I suppose you all know what this is. So first I'm defining a function called detect outliers. In that I'm passing my data set and the feature of my data set present in my data set. So for example, in the first step, we'll be passing DS will be, so here you can see our data set is train and our column name is item visibility. So these two things will be passed here, and I suppose you all know what this Q1, Q3 and all. So this is the first quartile and this is the third quartile. So meaning the second quartile will be the median. So our interquartile range will be difference between them. So to find the quartile, I'm using this function called quantile. You can look at the spelling in it. It is QUANTILE. So in that I need to pass the percentage of it. So first quartile is 0.25 and the third is 0.75. Our median will be 0.5. So I'm doing that for the particular column, and I'm storing them under the variable Q1, Q3, and difference between them will be the interquartile range. So IQR stands for interquartile range. So I'm taking the upper, this is the formula for upper limit and lower limit. So I'm calculating them and that will be returned. So our function returns the upper limit and lower limit. So that's this function. So first I'm calling my function and I am passing my parameters, which is our train data set and our item visibility column. And I'll be printing the upper and lower limit. And after that, I'm plotting a graph for it. So now with this, we are plotting a graph. We know this part already. So first I'm plotting a box plot before treating my outliers. Here first I'm selecting the records whose item visibility is greater than lower, and also it should be lesser than the upper limit. So that's the reason I'm writing these lines. So that those will be selected and those will be stored under the variable train, and same goes for the test variable also. And after doing that, we are again plotting a box plot, and this is what we get. So you can see this graph is drawn before removing the outlier. So there are clearly you can observe some outliers present in it, and after removing the outlier, this is our box plot. So we have used this interquartile range method to clear our outlier for the item visibility column alone. And now we'll be doing the same thing for item outlet sales feature. So you can see, so before removing the outliers, this is our box plot, and after removing, this is our box. So after we are done with the outlier removal, so now we need to correct our variable column named item fact content, as we have already noticed. So I'll write it again and just copy this name. So here you can see this low fat. So the first, a third, and the fifth one are same thing, but they are named as differently. So we need to correct that one. So for that I'm writing this function. So first I'm selecting my column, and after that using this map function I can change the names of it. So you can see I'm converting this low fat to the low fat itself, and this one to the low fat, and LF to low fat, and I'm doing the same for regular also. So these things are repeated for the test variable also. And after that I'm plotting a count plot. So moving on to the next one, we are changing the outlet establishment here. So we are dropping this outlet establishment here column, which has the opening year of each and every shops. So we are dropping that, and instead we are making a new column called outlet age. So to calculate the outlet age, we are doing this one. So the current year minus the year in which it is opened. So for example, if it is opened in 1999, our age of that shop would be 25. So that's what we are doing here, and using this del function I'm dropping those columns. So you can either use this del function, or if you are comfortable with the drop function, you can use that. So for now I'm using this del function, which is quite easy one. So using this del function followed by the column needs to be written, and after that it will be easily dropped. And I'm plotting a count plot for the new column that we made. So you can see, and you can also add colors to it, but you can't do it here because since we have already deleted these columns, and if you are again doing that, it will throw an error. So I will show that. So you can see there is a key error came, meaning this outlet establishment key here is, since it is already dropped, we can't find that. So I'm copying this and I'm running it separately. So here I can add colors to it. So it is speaking. So you can see we have added the colors. So if I'm replacing it with a rainbow, it will be good. So you can see we have added the colors to it. So after that, there are only several steps left. So the first one is encoding. So encoding is nothing but, so since our machine learning algorithm can only understand the inputs in the form of numbers, so we are encoding the categorical columns into numbers. So to convert them, we will be using several steps. So first one is a label encoding. So we are using the same mapping function to change this column. So for the outlet size column, small will be represented by 1 and medium by 2 and high by 3. And after doing this, I'm converting the data set of this column into integer data type. So I'm doing the same for this test column also, and I'm plotting a graph for it, count plot for it. So for the outlet location type, so first I'll just show the outlet location type. So you can see there are 3 things present. So from this, what I'm doing is, from tier 1, I'm just selecting this one, and from tier 2, I'm selecting this one. So from each and every tier, I'm selecting the final string present in it. So for that, what I need to do is, I can just slice this one. So first I'm selecting that column, and in that, as a string, so the negative indexing starts from the end. So -1 means the last element. So only the last element is selected. And after that, we are converting the data type into integer data type. So the column is converted into integer data type, and we are doing the same for test data set also. So after that, we are plotting a count plot. So you can see that. And looking at our data set, you can understand from the item identifier, DR, FD, NC and all those things. So FD means food, and DR means drinks, and NC means non-consumables. So we can make a new column out of it. So I'm doing the same thing, but this time we are slicing the first 2 elements present in the item identifier column, and I'm storing it under the new variable. So by default it will be in the form of integer only, so we need not explicitly convert them into integer. So that's what we are doing here. So after that, you can see the new column is created here, and our outlet age column is also created when we have created them. And now we are performing label encoding. So what this label encoding does is that, for example, in the low fat content column, there are only 2 categories present, like low fat and regular. So if we are performing a label encoding for this particular feature, what it does is that zeros will be represented by low fat and regular will be represented by a 1. So for example, if there are 3 categories present, we can index them using 0, 1, 2 and all those things. So that's what we are doing here. So first we are setting up our encoder. So label encoder, we have already imported them while importing our necessary packages. So here you can see we have imported our label encoder, and we'll also be using this polynomial feature standard scaler when it comes to modeling our machine learning model. And so yeah, here you can see we are using that label encoder. First we are selecting all the ordinal features. So only for these features we'll be performing label encoding. So I'm running a for loop for each and every item present in this list. So for that particular item, I'm encoding them. So that's the need for this line. So I'm doing the same for the test data set also. So after that, you can see we have got this phone. So we from this one you can understand, as I said earlier, for low fat is represented by 0 and regular is represented by 1, and the next column is outlet type. Supermarket type 1 is represented by 1, and supermarket type 2 is represented by 2, and grocery store is represented by 0. So likewise we have done it. So we are done with the label encoding. So now we can perform one-hot encoding. So what one-hot encoding does is that here we have converted them into numerical values, but here we are converting them into zeros and ones. So for example, so this item type column has totally 16 categories in it. So for this, if we are performing one-hot encoding for this column will be dropped, and there will be 16 columns created. In that, for example, the first column would be item type underscore diary. So for each and every category present in it, a separated column will be created, and if the particular product is belonging to that category, we will have 1 for it or else 0 for it. So this will be created based on the alphabetical order. For example, day will come after 4 or 5, depends on the elements present before it. So we are doing that, and for that we are using this get dummies function. So this will perform the dummification, and this is present under the package pandas. So first I'm using this function, and inside that I need to pass the data set, and after that I need to pass the columns present in it, and I want the original one to be dropped. So this one would be dropped. So for that I'm setting the drop first as true, and I'm doing the same for the test data set also. So after doing this, you can see there's an increase in the column number. So from this you can see a new columns are created. So I'll just list them. So from this you can understand that new columns are created for all these 3 things. So we have done with the dummification. So as of now we have converted all our features into numbers. So our machine can understand our input data set. So after this we are going on to the pre-processing step. So here we'll be just splitting our data set. So from the trained data set I'm removing the unnecessary column like the item identifier is invalid here, and same goes for the test. So we are dropping the item identifier column alone. And after that, so here is where I'm making my independent and target variable. So in my independent variable, I'll be dropping the target variable. So I'm using this, and my target variable only contains the target variable, right? So I'm doing that. So that's what I'm doing for train alone. So for now we'll be doing this for the train data set alone. So before selecting the model, we won't be doing anything for our test data set. So first I'm making the XY, and after that you can see this is what my X contains. So it doesn't have the target variable in it, and Y has our target variable. And using this function, which is train test split, so using this function I can split them into train and test data sets. So for now you can consider this one as our validation data set. So I'm making that. So this will be the order in which you must write. First comes the X train, then X test, after that Y train and Y test. So I'm writing that. So we have made everything. Then I'm making the split in the proposition 80 to 20. So meaning 80% will be stored in the train data set and 20% will be stored in the test data set. So I'm doing that. So next comes the modeling part. So we are modeling our machine learning algorithm with 4 different methods. So 4 different models will be made, and from that the best model will be selected. Only then we can make predictions for our test data set. So the 4 models are linear regression and regularized linear regression, random forest, and XGBoost. So first we'll go with linear regression, and everything what we do in this linear regression will be repeated for the all other 3 ones. So first I'm going with regular regression. So first I'm building my model with the default values present in it, and immediately after that I'm training my model. So first I'm doing that, and after that I'm making predictions to my test data set, which is used for validation purpose, and using this score function. So my model followed by dot score. Inside that I need to pass the dependent and independent variables, so it can calculate the score for our model. So the score is 55 for our train score and 54 for test score. So it is not at all acceptable. So next we are calculating with root mean square and R2 score, and R2 score is directly the accuracy score. So you can see these two are same, and root mean square shows the difference between the original and the predicted values. Next I'm finding the mean square error, and after that I'm taking the root of it to find my root mean square. Then I'm printing them, so it must be reduced as low as possible. So I'm going on with the next one. Next I'm normalizing them and adding a polynomial feature to our independent variables and the same regular regression. So I'm writing them inside a list the list contains tuples, and so that will be passed as a parameter for this function pipeline. So we have also imported our pipeline function. So that makes our model, and we are again training our model, and again we are looking at the scores of it. So you can see this is our new score, which is 60 and 56. So for now we are stopping with this one, and we are going on with the regularized linear regression model. So for now our test score is 56. So note that if we got any improved one, we can go with that. So next we are doing the same with regularized linear regression. For that I will be using this function, and inside that these parameters can be passed, and all other things are the same. So with this one, our accuracy is 5660, same thing is repeating, and our root mean square is also same. It is reduced, so we are considering this one. So let's go with the L1 regularization. So here also I'm following the same steps. So I'm making a prediction. So here you can see we have got 56 and 60. Accuracy is improved somehow. So from these two you can understand for our test score, it has 56, which is 56.65%. This gives the 56.7%. So till now, this lasso regression will be our best model. So after this, we are going on to the, we are taking the R2 scores also. So after this, we are going on to the random forest method. So I'm doing the same thing. I'm first building my model, and then I'm training my model. And after that, I'm making predictions. Then I'm testing my things. So here you can see there is a big change between my train score and test score, which says that our performance is the almost same, but it is overfitting. So we won't be going with this one unless we make any changes to it. So for that I'm performing hyperparameter tuning. So the parameter of this random forest can be changed, and I can select the best parameter for it. So for that I'm defining this function. So a function called tuned model, and first parameter will be my model, and the next two will be my dependent and my target feature. So here there is a set of features. So these are the combinations that I am setting. So which set CV does is that it will check for each and every combination, all permutation and combinations, and the one with the better cross validation will be selected, and that will be returned. So that's how I'm writing this function. So you can understand that. So but it takes some time. For example, this has something around 44333. So it is 4 times 4, which is 16 into, so 4 square, which is 4 square into 3 cube. So it should be 16 into 27. 16 into 27 means 480 minus 48, which should be, so 432 times it will be repeating. So we won't be having that much time. So even our CPU can crash. So for that purpose, I ran this thing in Google Colab using this TPU, and this is what the output I got. So with the output I got, when I used that, and my accuracy is a same 56, which is lesser than my lasso regressor, and the difference between the test score and train score is also increased. So it is overshooting. So I'm not going with this one. So then comes the HG boost. So for now, the best one is our lasso regressor. So which is, so if anything gives the accuracy greater than 56.7, I think. So our lasso regressor gate, yeah. So if our accuracy is greater than 56.7, we'll be selecting that, and it must also shouldn't overfit. So as of now, we are going with the lasso regressor. So the next one is HG boost. So if we are doing the same thing, we are checking if HG boost can do anything better. So you can see it is giving 48%, and I've done with the so I've also done hyperparameter tuning. These are the hyperparameter I got, And with that one, when I train my model, this is my output. So the test score is 51, which is lesser than my lasso regression. So I'm using this, I'm going with the lasso regressor. So lasso regressor is selected. So I'm going on with the lasso regressor. Only this lasso regressor is selected. So the model is stored under the variable called lasso underscore pipeline. So this is the name for our model. So we have found our model. So now we can make the predictions. So using this one, and I'm making predictions for our test data set. So the predictions are stored in here. So you can see these are the predictions that we made. So finally we are storing our model. So I'm using this pickle function to store the model. So this is very easy. You can see that I'm calling this pickle. So we have also imported them initially. I can import them again. So import pickle. Using this, you can import the pickle, and you need not even install it. I think it is present by default. And using the pickle, under pickle, so we'll be using this function called nums to store our model. And inside that, I need to pass the variable that needs to be stored. So I'm passing the variable for my model. So our model is stored under the variable lasso pipeline. Then I'm using this function to open up this file. If it doesn't exist, we'll be creating that one. And don't forget to store it with the extension .pkl. So after that, the method I'm using is wb. So w stands for writing, and the reason I'm writing b is that if anything that we are storing is not in the form of text, other than text, we'll be using this one. So it will be converted into binary and stored. That's the reason I'm using this one. So this line stores our model. So here you can see this is the place our notebook is present. And after running this one, you can see this one is loaded in here. So that's the reason. So that's how it is done. To load our model, it is also easy. We are again using this pickle function, and under that I'll be using this load, and inside that I'll be passing this one with the method read. So using that I can load my model, and when I look at my model, it is present like this. So you can see this is my model. So that's it. So this is the end of my task 7, which is BigMart Sales Predictions. We have developed the model, we have looked at our data set, we have understood it, and we have treated our data set, and we have made some predictions out of it. So for now, our accuracy is something around 57, I think. So that's our accuracy in finding the sales of a particular product in a particular shop. So that's it. Thank you. Thanks for listening. Thank you.